both for the invitation and for helping me get set up here today. We're going to kind of cross the spectrum today. We're going to be looking at some amateur astronomy, very basic stuff, up to the new James Webb Space Telescope. So we're going to look at quite a few different things. But just a little bit about me first. I'm a member of the Syracuse Astronomical Society and the Mohawk Valley Astronomical Society out of Waterville, both of those. I'm an enthusiastic amateur astronomer. I'm not a professional astronomer, so I will try my best to answer questions, but there may be some things I'll have to defer to the internet. We'll see how that goes. I'm a retired high school English teacher, math teacher, and department chair. I taught 23 years at the Sherburne-Earlville High School and 15 years in 2 high schools in Indiana before we moved here to upstate New York. I'm the husband of a history professor at SUNY Cortland, the father of 2 sons, and the grandfather of 3 boys. So just a little bit there. Now, I thought we'd divide the day up into 2 parts. And the first part is going to be kind of basic astronomy, where we'll look at basic telescopes, aperture versus magnification, expectation versus reality, views through an 8-inch Dobsonian, which is what I have here, the challenge and the eureka, and then other parts of the fun. And then in the second part, this is where we'll get into the James Webb Space Telescope, where we will look at surmounting the immediate challenges of just getting this thing up into space. Its all-important sun shield, the Lagrange point number 2. Right off the bat, is that a brand new term, or has anybody ever heard of that before? The Lagrange points? Okay. Hubble versus Webb. Why infrared? Because the Webb is an infrared telescope, much more about that. Some of the early images and then some of the early surprises, even though it's only been online for 3 or 4 months at this point. Okay, so basic telescopes. There are all kinds of telescopes, but you can kind of divide them into 2 main categories, a reflector or a refractor. Now, without any more clues from me, take a look at mine down here on the floor. Can you figure out which of the 2 categories it's in? Which would it be?
Reflector.
It's a reflector, yeah. And if you look at the 2 pictures up here on the screen, they look very similar. They're both about the same size. They're both white. They're both on tripods, but there's at least one very important difference, which you can use to quickly tell which is which. Can you see one really important difference?
The lens is deeper.
I think you're onto it, yeah. My eyepiece fits up right in here toward the top, toward the hole. This one has the eyepiece in kind of the stereotypical telescope mode at the very end of it. Almost like the spy scopes, you know, like you see in pirate movies. It's very much that thing. Well, these are set up with a series or at least one lens. So when the light comes through, it immediately hits a lens which is focused down here and then out through an eyepiece. My scope doesn't have any lenses. It just has a big mirror at the bottom, if you can see that. And the bigger the mirror, usually the more impressive the scope, if you can see that. So in a reflector, the light comes in, bounces off that parabolic mirror so that it is focused right about here. And then there's a little secondary mirror which takes that and reflects it back up into my eyepiece. So nothing happens in terms of the distortion of the view in my scope until I get it into the eyepiece. Whereas here, it's immediately altered as soon as it hits that lens and comes down. Now, the mount, this base that mine is sitting on, is just as important as the scope itself. It's got to be very solid, very much so that it's not going to be moving around much. Because mine, when I get it focused, even though this is a nice solid base, if I'm on my little chair here in front of it looking into it, and I move it ever so slightly, I messed it up. So there's got to be a very solid base. This one is called a Dobsonian base, after the guy who invented it only 30 or 40 years ago. James Dobson was his name. And it's pretty basic, but it's also pretty clever in that it allows both left and right motion and up and down motion. Excuse the squeak there. So it's very easy to adjust. But if you don't have that good solid base, that kind of ruins everything. Now, the eyepieces that I have for this particular scope are over here. And let me hold up the three basic ones. This is a 30 millimeter eyepiece. This one is 9 millimeters, so it's in the middle. And this is 6 millimeters. Now, which of the three do you think would provide the more magnified view? The little one. The little one, which is kind of counterintuitive. It's the littlest eyepiece that provides the biggest magnification. This one, the 30 millimeter, gives me a nice wide view of the sky, but it doesn't magnify it in much. This one would magnify what I see at about 40 times. This one, the 9, would magnify it about 133 times. This one, the little guy, would magnify it 200 times because of the lenses that are inside. Once again, the scope has no lenses in it. The lenses occur in the eyepiece. So this one can go up to 200 times. Now, I have this other lens over here called a Barlow. And a Barlow is kind of a magic device. I can take this and put any lens into it, and it automatically doubles the power. So that little one that I had that was a 6 millimeter or 200 magnification, I plug it into here, and all of a sudden I'm up to 400 magnification, because there are more lenses in here that make that one even stronger as it goes. Okay. Now, aperture versus magnification. Aperture is the width of the opening of the scope. This is the aperture. This is an 8-inch aperture. Magnification, I think most people realize, that's how much the image is enlarged. Which do you think is more important? There are a lot of things about telescopes that are kind of counterintuitive.
Aperture would be,
Why would you think so?
because if it lets in more light, you get a better picture.
Exactly. The more light that can be gathered, the better. I could take these same eyepieces and put them on a 10-inch scope, or a 12-inch, or a 20-inch, even larger. And then the more light I get, the brighter the image, the clearer the image that's going to be. So some people would say aperture is more important. More light that is gathered, the brighter the image. But that doesn't mean that magnification is unimportant. It's just that the higher the magnification, the smaller the field of view and the duller the image. Okay. Each telescope does have a maximum before the image just gets too blurry and is no longer really usable. And mine is right around 400. They can't really do anything beyond that. And it's rare where I would try to do something at that high of a magnification, because even then it's not usually too good.
So how far, I mean, if you were in your backyard and you want to see something in somebody else's backyard, maybe something's going on. So maybe they're having a party and you didn't get invited and you're wondering who's there. So how far away, how many, just a normal kind of backyard, how far away could you see?
Yeah, of course, that's a
So it isn't blurry.
Yeah, that's kind of an apolitical use of telescopes. But you could say probably 2 or 3 houses away if it's an average neighborhood, because it's got enough power to it that it's not going to do very good on stuff that's up close. Especially when you consider these things can see objects that are millions of light years away. They're designed for great distance as opposed to short distance. All right, now, You probably have seen many pictures like this before. This is a beautiful galaxy called M81. It's very close to the Big Dipper up in the sky. Now, even though that's a wonderful image, it's a beautiful image, it's frameable. You could go to the most powerful telescope on the planet, look through the eyepiece, and you would never see that. You would never see that. The colors have usually been added. Now, that immediately sets off alarms in people's heads. They think, oh, it's all a big lie. You know, it's not really what it is at all. Well, that's not true. That's not true. It just happens that a lot of those beautiful colors there are in the infrared spectrum, which we're going to be talking about more in a little bit, and that we can't see. We simply, our eyes cannot see the infrared. So even though these are genuine parts of the galaxy, they're not parts that we could see. So scientists and astronomers have added colors to make them more workable, for all their studies. They sometimes use particular colors for particular gases too. For instance, red is often used for hydrogen. Green, or sometimes even blue, which I've seen, is sometimes used for oxygen. So by plugging into their computers, any gas that is hydrogen automatically colored red, and the same with those other ones. It gives them a good visual for what they are actually looking at. Okay?
How do they know that? If they're looking at it through a telescope, how do they know what the gases are?
Yeah, often through the infrared, just what we're going to be talking about. That's what the Webb telescope is so good at, seeing the infrared, but other telescopes can too. And there's a complicated thing in both physics and astronomy called spectroscopy, if I can say that correctly, where they would take the light that they see, shoot it through a prism, and then it breaks it up into its chemical elements. So they can thereby determine which one of those gases are predominant in that case. But if I were going to see this through my telescope, and I have seen M81 through my telescope. It looks more like that. Now, you can say that's disappointing. And in one sense it is, but as I'm going to talk about in the next few minutes, the real eureka moment here is just finding the darn thing up in the sky, because it takes quite a bit of skill to get it to where you want it to be. Also, I'm going to show you some pictures of wonderful objects that aren't this dull or aren't this small, that are true to color through this scope right here, or ones just like it. This kind of talks about what I was just saying about how scientists colorize things for their own purposes, so they can see through. Another expectation versus reality. The Ring Nebula. This is up in the constellation Lyra, which is where the big bright star Vega is. It's a wonderful, wonderful target. It's what they call a planetary nebula, which means that it probably resulted from a supernova in the past. This is now what's left. Those colors, once again, have been added. If I went to that same powerful telescope, the most powerful one on the planet, I would still not see it in those colors. I saw it last night, though, in my driveway with this particular telescope, and it looked very much like this.
Oh, yeah.
Very much like this. Okay. Now, fused through an 8-inch Dobsonian. My telescope is not set up to take pictures. Okay, but I've gotten pictures off the internet from other 8-inch Dobsonians that did have cameras. So what you're going to see here is very similar to what I have seen. Okay, here's the good old Big Dipper again. And do you remember the old memory trick here? How you can find Polaris, the North Star? You take the two stars at the back end of the cup and they kind of point to the North Star, so you can always find it. Well, what I'm interested in, though, here is this next to last star in the handle. Now, when we look at it up in the sky, it looks like a single star. But as you can kind of tell by the name there, that's not a single star. When I look at it through my telescope, there are actually 3 stars there. Mizar and Alcar are so close together up in the sky that they appear as one. And it turns out that Mizar itself is actually 2 stars. So this one little pinpoint of light that we see up in the sky is really 3 stars. Now, this blew my mind when I first learned it, but it turns out that all the stars that we see up in the sky, at least half, and probably more than half, are double stars or more. It's incredible. This little one here is actually not part of the trio. It's just kind of a stray one that has wandered into that particular photo. Okay, some more. This is another double star, Cygnus. Deneb up here, have you ever heard of the summer triangle of stars? Okay, Deneb, Vega, and Altair, this is one of them. This is supposed to look like a swan, if you can kick in your imagination. Well, the very bottom star here, Alberio, is another example of a double. With true colors, it looks almost exactly like that. It's a goldish star paired with a blue star. It's so pretty when you see it up in the actual sky. It's just amazing. This is my favorite one. Anybody even know what that is? This is called the Pleiades. The Pleiades. It's an open cluster. It is so glorious when you see it up in the sky. This is a wonderful picture, but I've seen it even better than that. It does have kind of bluish color to it because some of them are kind of nebulous around it. And I've seen it where it's blown up much more than that through this scope as well. But now, see if you can figure out why in the world am I throwing this up here? Any of you drive Subarus?
Yeah.
I do. Do you know what this is?
Pleiades.
This is the Pleiades. Yeah.
Although where is the seventh of the 7 sisters?
Yeah, they don't have it there. Yeah. Pleiades is the Japanese word for this system that you see there. So they have named their car blind after this whole phenomenon. It's pretty cool. Another one. Yeah. This is called a globular cluster. And I have seen, once again, this just as good as you see it here, if not better. This is the Hercules cluster in the constellation Hercules up there. These are almost like little mini galaxies. This is basically anywhere from 100 to 300,000 stars, all combined basically in this tiny part of space, almost like a little mini galaxy. They are some of the oldest structures in the universe, and they're all over the place, all over the place. And there's Andromeda, which I also saw in my driveway last night. Andromeda, the nearest galaxy to us, very comparable to the Milky Way. And once again, just finding it is really a major part of the success.
What is that cloudy part in the middle? Is that the interior?
Yes. If you saw one of those fancy colorized images, it would be much bigger than this. So what I can pick up is just kind of the most central part. But a good part of most galaxies is the gas. The gas that does combine to keep on forming stars.
That's why it's milky looking?
Yeah, exactly. Exactly. But there are other things that I can see in my scope with color. Orion. Anybody know how you recognize Orion when you see it up in the sky?
The 3.
Yeah, which is supposed to be the belt of Orion the Hunter. Well, just below the belt, it's in what's called Orion's sword, is this part called the nebula. I have seen it colorized just like this, not so much the red, but I have certainly seen this green for the oxygen that is present there. It's just glorious. It's just glorious when you can see it on your own. And I saw this much. What's that? Jupiter. Yeah. Often you can see it with 4 moons. In this particular image, you can see it just with 3. And notice you can get the bands of color, once again on this, just through a fairly basic telescope like this. And here's Saturn. What I saw last night was an especially good night, was even a little clearer than this. One thing we always try to see when Saturn is up in the sky, Can you see what's called the Cassini Division, which is that dark band that separates some of the rings? Can you even see a little bit of the shadow from the rings on the planet? Can you even see some of the bands of color on it? And once again, last night, all of those were visible. They were all there. But then this one is the one that I saw for the first time 4 or 5 months ago. Sagittarius, that constellation, there was a part of it called the Sagittarius small cloud, which looks like just the entire field is loaded with stars. There it is. Yeah, I have seen that once again through my 8-inch telescope. It's just phenomenal. So can I see pretty galaxies that are all in color? No, but so can nobody else. But I can see all these things that I have shown you here in the last few minutes. Now, the challenge of finding these things, finding what I want. First of all, you have to put up with the two banes of any astronomer, clouds. And I don't know how many times there has been a wonderful forecast and you get all set up, which takes a bit of work, and then the clouds roll in, so it all gets canceled. And light pollution. I live in Hamilton, a fairly typical small village, but right across the street from my house, I've got 2 street lamps. And you wouldn't think that just a street lamp would interfere with things much, but they do. They do. So you have to try to look at other parts of the sky. And last night there was something else up in the sky that was preventing a long night of viewing. The moon. Yeah, the full moon last night. It's wonderful to look at, but have you ever noticed how the moon really does shed light? It can light up an entire backyard for that. Did I see a question?
Yes, I had a question, but go ahead and finish with it.
Oh, no, that's fine.
I wanted to ask you, are there parts of the world, because of their height or their atmosphere, that you see things better than in other parts?
Absolutely. Absolutely. This is they give it a fancy scale called a Bortle scale. And the lower the number on the Bortle scale, the better the viewing. Hamilton, as a typical village, is called like a Bortle 4. So it's kind of in the middle. But the Syracuse Astronomy Society has a site just south of the city near Tully on a very dark hillside. So I think if you're there where there are no lights discernible, you can see the city off at a distance. I think that's down to a Bortle 2 or a Bortle 3. But then some of the areas in the southwest of our country in particular, there you can get almost perfectly dark skies.
Because they're lower?
Lower, and because there just aren't the lights around. Yeah. Big city lights kind of make their own glow. Yeah, which bleed in from all of that. Yeah.
I have to go back out west again.
Yeah, definitely. Well, aiming a telescope, this is another challenge, is surprisingly hard. I'm trying to find a given speck of light on the sky through this. And I didn't bring it, but I do have a little chair that I sit here with. The first thing I have to do is kind of get my head way down here so that I can try to line it up almost mathematically through this little finder scope. Now, you might wonder, why would I even bother with this when I've got this big scope here? Why not just go for this automatically? Well, it turns out this is a better way of finding what you want, simply because it's a bigger aperture. You got to remember that 8-inch aperture is just for gathering light. All it does is gather light and then reflect it back up to here. So when I really start looking for things, this is the aperture or the field of view, so to speak, that I can see up in the sky. And this has a wider field of view than that does. So it's very low magnification. This is only 8, but that's good. It shows me quite a bit of the sky when I look through this first. So that's where I would try to find things in that finder scope. Then, once I found it, I would try to find it also in the big scope, and then by making some adjustments, trying to get it so it's right in the center of this one, and also right in the center of this one. That way, when I start moving around from target to target, the two scopes, this is like a little mini scope, are aligned at that point. Then star hopping. There are many, many, many astronomers, amateur astronomers and professional these days, who have what are called go-to telescopes. And that means basically computerized, where they have a little keypad and they can simply type in the coordinates of the object they want, or sometimes even just the name, and the scope will magically transport itself and then find it for you, so you never have to do it. I don't have that kind of scope. I'm a little wistful about that, but I'm not sure I want one. You know, because part of the fun, part of the challenge is being able to find it yourself. It forces you to understand the sky, to learn the sky really well, so that you can start getting these things more and more on your own. So there's this process called star hopping, which kind of defines itself. This is the target I want, but to get there, I'm going to try to find this bright star first, and then jump to this bright star, and then jump to this one, and this one, and this one, and almost like climbing a ladder, eventually get up to the target that I want, which is probably much dimmer than the stars that I use to get there for it. Stellarium. If any of you are really interested in this, Stellarium is a totally free piece of software that you can download on your computer. And it gives you kind of like your own personal planetarium. You can find anything on Stellarium that you want in this beautiful night sky. I made one little picture of it here. When I find it, here's two results. Either I start screaming with joy or I start throwing it. One of the two. But this is one page from Stellarium. And I know you're not going to be able to see this much in the lights that we have here. But let's say that my goal is to go for this Sagittarius cloud. Remember that picture I had up here just a little while ago with the whole field of stars? Okay, well, it by itself is very dim in the sky. I wouldn't be able to just find it and aim for it. What I would probably do, and what I've done before, this, if you can use your imagination once again, are the main stars of Sagittarius. It's supposed to look like a teapot. If you can see that, it's a teapot that's kind of tilting over and then spilling out. Well, Nunki in Sagittarius is a pretty bright star. So I would probably aim for that one first, then maybe star hop down to this one, then maybe star hop to this one, then probably this little kind of mild star there. Any kind of pattern is very helpful, so I would look for that little S, and if I can find all of those, then I should be able to jump up just a little bit, and there's what I really want. This can sometimes take 30 minutes, 40 minutes, 50 minutes, depending on the conditions, just to find the thing I want, because it's so dim up in the sky. Then when I find it, there are several things here. First of all, and I'm trying to teach myself to do this more and more, just drinking in the beauty of the object. These things are phenomenal when you see them up in the sky. Andromeda, once again, even though it's kind of grayish and not all that bright, you have to think for a minute, what are you looking at? And what does that mean? What it means really is that photons, those little pieces of light from that galaxy, traveled 2.5 million light years through space, entered my 8-inch telescope, bounced off the mirror in the back, bounced again off the little secondary mirror, up through the eyepiece into my eye. That's pretty amazing, you know, when you think about it. We don't have time to really get into this right now, but have you heard that old story that telescopes are basically time machines? Mm-hmm. It's true. It's true. This is not a made-up figure. That is true. Andromeda is about 2.5 million light years away. That means that it took 2.5 million years for that light to travel through space to get to us here on Earth. So what I looked at last night in my driveway was what Andromeda looked like 2.5 million years ago. That is not an exaggeration. That is the gospel truth. Thinking about all of that, you know, is really part of the whole beauty of the hobby, I would say. It's also fun, you know, like with anything you get into, just to keep a log, and I do this, it's just I keep track on my computer. This is the 2 entries. I think I'm up to page 32 or 33 now. This is from last November. You can see what I was successful in seeing that particular night, where I was. That particular night, last November, was my first view of Uranus. It was very small, bluish, and rounder than stars, etc. But it's fun just going back and looking at that. But then another thing to do, which is fun, there was a famous French astronomer from about the time of the American Revolution called Charles Messier. And Messier was one of the first to come up with a catalog of what even back in the 1700s were very bright, noticeable objects in the sky with the telescopes they had of that age. So his list came up with 110 of these. So most amateur astronomers try to eventually find all 110. I'm up to 75. Now, the problem with that is that you can see maybe from where you're sitting, this last column here, which says difficulty, and these range from very easy to very hard. Most of those 75s were the easies. A few moderates. I think I found 1 hard so far. So the last 35 are going to be a real challenge. Once again, if I had a computerized scope, I could simply type in M23, and it would take me to M23. But I don't really consider that much of a challenge.
So, given the time capsule
Yeah,
portion of this, are any of them no longer there?
we don't know.
Yeah.
I mean, we have a pretty good idea that they're still there.
But any of his, are there any that you can no longer see?
No.
Okay.
No. Some of them are, a few of them are what we call the planetary nebulas. Remember that ring nebula that we had up here before? That is M57, SEA 57. So those are the remnants of a former star that went supernova. But we still see the remains of it.
So when was the first, even no matter how primitive, when was the first telescope?
Yeah. Anybody remember the scientist who's at least credited with developing the first telescope?
Galileo.
Galileo, yeah. With his moons of Jupiter, he saw those with his primitive telescope. Yeah. Yeah, there are some wonderful
Quick question, Chip.
Oh, yeah.
Messier objects presumably are all visible from the northern hemisphere. Are there additional ones had he, I mean, I have to assume there'd be additional ones had he gone to
Yes.
South America to view.
I don't think Messier has any, but another astronomer of about the same time, William Herschel, he also had an expanded catalog of the Messiers. He died, but his son, and I think his son's name was John, did the very thing that you're talking about. He wanted to go down to the southern hemisphere and find the constellations that were there. So his contributions were many of those down there, which had never been included before. Astro Backyard. This is probably the most with high production values, I would say. This guy, his name is Trevor, what is his last name? Can't think, but he's from Canada. And you can see he's got a fairly fancy astrophotography rig here. He goes all over the place and puts new blogs on his webpage there fairly frequently. This is another guy named Nico Carver from Nebula Photos. You can see he's got a couple very fancy rigs. They're quite easy to see on YouTube. But then there are the astronomy clubs that I mentioned before. And these are from the Syracuse Astronomical Society, once again, near Tully. This is our big 16-inch reflector. Once again, mine is an 8-inch, so the bigger the opening, the bigger the tube that is needed. Notice that you have to get on a little ladder to get up to the eyepiece on that one. This is actually the observatory here. This is inside of this. So the roof rolls off so that it opens up to the sky so you can see this. But the nicest thing about that site on this wonderful hillside around Tully is that it's open for any astronomers to come with their equipment. So when I go, I take my scope with me so I can take advantage of those dark skies that we talked about before. But I'm also part of the Mohawk Valley one. This is right behind the library in Waterville, if any of you know where the library is there. They also have, it looks just kind of like a shed, but this truss structure here is to support the roof when they roll it off. They have a very impressive 16-inch, this is called a Schmidt-Casson grain, which kind of puts the properties of a reflector combined with the properties of a refractor all into one. Very expensive, very wonderful scope. That's it for part one, before we get into James Webb.
Oh, wait, the high school, Fayetteville Manlius High School also has an observatory, and I believe they have public viewing nights.
Oh,
So you
great.
don't have to drive all the way to Tully.
All right, yeah.
How do you find
Yes.
out? Just call the school?
When my father would turn 65, his doctor, neighbor, friend, couldn't think of what to get him. He actually had a star named after him.
Wow.
And I wondered if you're familiar, I mean, this is some kind of, I mean, it looked, I mean, there was a certificate. And I don't know what, we can't find it now, so we don't know part of the sky. But I wondered if you had ever heard of that. People could actually have a new star. I mean, is it really going? I mean, do people do that?
Yeah.
It's kind of unique, you know, here, Charlie, didn't know what to get you, here's a star.
Yeah.
It's kind of like the websites where you can buy 1 square foot of Scotland.
Oh, okay, I think maybe it was a joke, but, you know, saying that there are new
Sure.
stars and being discovered all the time. I
Yeah.
wonder how much money you have to put up.
Do you have any idea when this would have been?
Yeah, well, it was back, and it was probably 30 years ago.
Okay, yeah. My guess would be, and this is just a guess, that could have been something of earlier days that doesn't happen too much now. I have heard of asteroids these days sometimes being tied to the discoverer, with the name of the discoverer being
Right.
tied to the
With the
asteroid.
name of someone, right,
Yeah.
well, I figured it was.
I think what you started, there are with trillions of stars out there.
Oh,
There
yeah.
are star registries, so there's a
That's
lot of
right.
opportunities to say,
Yeah.
nobody has named this one. Let's go to the registry and call it Fred.
Yeah.
I didn't mean to take up this
Oh, no.
time with that question.
No, that was
I
fine.
always think of both of my parents are up there.
There
Yeah.
you go. I just gotta find it.
Yeah, I know, and maybe I don't need to really pinpoint. I'll be lucky to see, it's not cloudy and I can see some stuff.
Stick with your pictures.
Yeah.
The good news is with so many stars, you can just tell me, hey, there's.
I
Fred, and
have
I'll
no
bring it.
idea.
Who's 28 years old.
Yeah.
I think this would interest him. Where would you begin at a nominal price and an instrument and a book that he's smart enough?
Yes. There are lots of those YouTube sites that I would recommend, and several of them answer that basic question. What scopes would you recommend for a beginner? That kind of thing. So if you simply did a search on YouTube for beginning astronomy, I think you would find a lot. This one I got about 2 years ago. And it was interesting, a little footnote before I even take that farther. During the pandemic, when we were at the height, astronomy skyrocketed. There was great interest in astronomy because it's something you could do on your own in your backyard. So since that time, prices have gone up. This scope was just around 600 when I bought it a couple of years ago. Now it would be about 750 to 800. And that's not counting all the lenses and everything
Yes,
else.
right.
So,
And what about the 16-incher?
boy,
Would that be?
that is, the one in Tully is an older scope. It's been there. You might even know the answer to this too.
Yeah, I'd have to go into our archives. The Technology Alliance of Central New York contributed money to SAS to purchase that,
Yeah.
35 years ago. So I don't know if we bought the whole thing or a part of it, but I'm sure in today's dollars, you're talking many thousands.
Yeah. The 16-inch that's in Waterville which was donated there, I think about 10 years ago. If I had to estimate a price on that, I would say probably 15, 12,000.
There are a lot of price points. I mean, you can even get binoculars that will allow you to see certain things. It depends, you know, if you want to go easy and just say, hey, you know, my app on my phone says that bright star is actually Jupiter. You know, you can see that with a, you know, not your average backyard binoculars, but there are higher powered ones for star spotting.
Yeah.
And saw one before. I won one at the observatory in Tully. It's a backpack one. It's about yay big. I can guarantee SAS didn't spend thousands of dollars for it. So, you know, they're probably price points starting at $100 and up.
Yes.
The place in Tully or in Waterville, is it ever open completely to the public?
Yes. Yes. There are relatively modest membership fees yearly. I think the Syracuse membership fee is now around 50, but I think in Waterville, it's just like $15. But you don't even have to be a member because each month they have both member nights and then they have public viewing nights each month. You have to kind of watch the schedule because sometimes, more times than not, actually, the clouds will roll in and it'll get canceled. But they try to do it around new moon night because new moon is when there is no moon in the sky. So it's the best view.
SAS typically doesn't do it during the winter because they don't plow the road up to the
Right.
observatory.
Right.
Yeah.
And they don't do it during the summer because sundown is so late that nobody wants to go out at 11 o'clock and
Yeah.
watch. But if you follow them on Facebook, they'll announce whenever it's open to the public.
Okay.
And if you are a member of the place, you can go whenever you want. You don't have to wait for one of those member nights or public nights. You can go anytime.
Try it before you buy it.
Back on the telescope thing, this is a recommendation that you'll hear astronomers make all the time. You do get what you pay for. And you can find department store telescopes that seem pretty impressive when you look at them for maybe $200 or $300. I wouldn't do so. Usually those are pretty bad telescopes. They're not going to be attuned, and they're not going to be calibrated. The mirrors aren't too good. You're not going to be able to get them focused too well. So looks can be deceiving on that.
If they're lightweight, the breeze will move it so that, you know, you can't find anything.
Yeah.
They don't do tracking. You know, the stars move during the night as the Earth
Right.
rotates.
These are wonderful questions. Please keep them coming. We'll move in here to the second part now. James Webb Space Telescope. There it is. There it is. And just some basic facts and figures here first. You probably have seen this before, but these are 18 hexagonal mirrors that have all been kind of affixed together to make one working 21-foot mirror. 8 inches compared to 21 feet, that's going to gather a lot of light. You know, this room, I would guess, is somewhere between 20 and 25 feet across. You know, just to give you an idea of the size of this thing. The mirrors do gather infrared light, more about that coming up in a little bit, which is invisible to the human eye. And the mirrors are coated in gold. Have you noticed that? And that is pure gold, because gold is a great reflector of the infrared. 99% of infrared light that hits these gold-plated mirrors is reflected just the way they want to. So it's a very, very ideal mirror. Now, some of the immediate challenges. This is another one of those little facts that just kind of blows my mind. Before the thing was launched, and I had to remind myself, it was launched last Christmas Day. Remember that? Mm-hmm. Yeah, on Christmas Day. At that point of launch, to the point where it finally got into the orbit where it's going to stay, there were 344 possible points of failure. Now, what that means is that if any one of those 344 had failed, the whole thing's off. The whole thing's off. It's not just that, okay, well, we'll have to make do with 343 instead of 344. No. If any one of those had gone wrong, the whole thing would have come figuratively crashes down. All 344 were met. Just staggering. Now, unlike Hubble, which is still up there, still operating, still a wonderful telescope, it's about 340 miles above the Earth. Well, the Webb is literally 1 million miles from the Earth. It can't be repaired. Hubble, we were talking about this a little bit beforehand, when Hubble was launched in 1990. And if you remember how it didn't work when they first got it up there, there were some problems that they were not expecting. So they had to send up the space shuttle with some astronauts. And it kind of became a joke. In effect, those astronauts put glasses on the Hubble so that it could focus the way it was supposed to. It was a wonderful, miraculous repair. Can't do that with Webb. Okay? Yes.
I just wanted to say, during that time frame, the early 90s, I was on a plane flying from Boston to LA, and this guy was sitting next to me. I used to work for Apple Computers, so he was asking me all these questions about Apple, like he was so interested. And we, you know, half an hour into the flight, I said, "What do you do?" He was one of the engineers that was going to repair the Hubble. What am I talking for? You know? I was shocked. And then when I retired from Apple, I taught computer science at FM. And we had this robotics club, and we went to this competition at MIT where the kids wrote programs that the international, what do you call them, the engineers on the International Space Station were going to run their programs and see how things worked.
Wow.
And the guy presenting at that was the guy that was on the plane.
Yeah.
So that's
Yeah. Did he by chance remember the flight?
No, the kids, I was telling the kids, the students, and they said, "Well, go up and tell him afterwards." I'm like, that was like 25 years ago. I'm not going to remember me, but I just remember because he looked so familiar. And then we started talking, and now I can't even remember his name. That's how old I am now. But when I was watching his eyes, I went, "That's the guy."
How neat. How neat.
I guess he was successful. He did it. He fixed it.
Yeah.
They fixed it.
Little perspective about that 1 million miles. That's like about 4 times the distance of the moon. That's how far out it is. You know, we have never traveled that far out. Okay. Hopefully we will sometime soon. But you know, yeah.
Must grow.
And there are perhaps some software fixes. You know, if there are simply some computer programs that have to be adjusted, that they can do here. But in terms of the hardware fixes that Hubble needed, there's no way that can happen here. So we've got to keep our fingers crossed. Now, this is a wonderful little video. It's only about 1.5 minutes long that kind of illustrates the intricacy of how this thing had to be unfolded once it was up into space. Some people have kind of called it the Origami Telescope, and you'll see what they're talking about. So this shows you a lot of those 344 things that could have gone wrong, but that didn't.
There was some kind of a toy we could buy that was very much like pieces. Like
Would that be
all
neat?
the glasses, like for the kids.
So this is 2 hours after lunch. 3 days. These are the sun shields that haven't been uncovered yet. Covers coming off of the sun shields. And now they're going to stretch out those sun shields, almost like an umbrella.
These are the points of possible failure.
A lot of them, yes. And none of them failed. They all worked just the way they're supposed to. Notice it's got a secondary mirror, just like mine has.
Ship,
Yeah,
get it ready to go.
yeah. And now the 2 sides for the mirrors have to come up and lock in place. pretty impressive. You know, you can understand why these NASA scientists, you know, when they get a successful launch up, they all jump to their feet and sort of clapping, you know, because there are so many things that have to go right just to get the thing up in the atmosphere, let alone all this that happens too. Now, the sun shield. Here's a picture with a bunch of people in front, so you can just kind of get an idea of the size. Infrared telescopes, such as Webb, need extreme cold to operate effectively. Infrared is kind of measuring the heat. Have you ever looked through night vision goggles before and seen those kind of spooky images of people? They often show up as red. That usually is infrared, and it's picking up their heat signatures. So for this to be able to work, all the heat has to be gotten rid of somehow. And this is a neat diagram that shows how those 5 layers increasingly deflect all that light and heat as we go. So the sunlight that strikes the first layer, most of that is going to get deflected. But some of it's probably going to bleed through. So more of it gets deflected into the next one. More gets deflected, more gets deflected. So very little heat gets through all the layers to the cold side of the telescope. In fact, only 1/1,000,000th of the heat penetrates all 5. So they are amazingly effective for this. Now, this is the term that we mentioned briefly at the beginning, the Lagrange point number 2. Well, any 2 bodies out in space, like a sun and a planet, have these 5 Lagrange points where the various forces that are pulling on objects are kind of balanced. So, as the Earth and the Moon orbit the sun, these 5 Lagrange points are where the gravity and centrifugal forces are almost balanced, so that something kind of floating at this point is no longer pulled in from the gravity of the sun, but centrifugal force. If you can think of those amusement park rides that go in a circle and how you feel yourself being thrown to the outside of the circle, okay, that's centrifugal force. So the centrifugal force and the gravity kind of cancel each other out at these Lagrange points. So it's a wonderful place to park a satellite or a telescope in this case, so that it doesn't have to deal with all the usual things that you would have to deal with up in space. Now, combine gravity from the sun and the Earth at L2. It's almost like it provides a tether or like an invisible rope to the James Webb Telescope, so that as the Earth rotates around the sun, that tether, that invisible tether, is just going to pull the telescope along with it with no effort on the telescope's part. Now, it's never perfect. It's never perfect. So it needs a little bit of fuel to be able to make adjustments as it needs to. But they have already discovered in just these first 5-6 months, they thought the Webb would have enough fuel to last about 10 years. They're now thinking they've saved enough fuel, it's going to be working, they hope, for 20 years. Okay. So it should be out there for quite a while. It completes one orbit of this invisible L2 point in about 6 months. Now you might have the question, well, why not, as I kind of alluded to a minute ago, why not just park it, so to speak, at the exact L2 point? Well, the whole purpose of the telescope is to see as much of the sky as it can. So by having this relatively little orbit around that point, with the sun shield always blocking all the sun light and heat as it rotates around the Earth and as itself rotates in that 6-month orbit, it can see the entire sky, the entire sky. And we're just starting to get some of those images now. Now, this is another little, this is just a 20-second video that kind of illustrates what I was just talking about. You'll see the little telescope here at L2 not only circling in its little orbit about that imaginary point in space, but you'll see it going around the sun with the Earth on that imaginary tether as it does so. So the sun shield is always pointed toward the sun. Always, always, always. Pretty cool. Yeah.
Very good.
The design behind all this, is just staggering in many ways. Okay, well, Hubble versus Webb. This you may have seen before too. This was a deep sky image taken by the Hubble telescope probably 20, 25 years ago. Those all look like individual stars. Those are not stars, except for these big ones. Those are stars. Do you know what those little points of light are? Those are galaxies. Each one of those is like its own little Milky Way. Not even little, just big, just little on the picture. Beautiful picture. Beautiful picture. It's gotten a lot of press, since Hubble has been up there. Well, they wanted to take a picture of the exact same spot with Webb. Okay, so here's Webb's version of that same spot.
Wow.
Okay. Now, it's still impressive. It's still impressive, but there's much more that can now be seen. Not only are there more galaxies that can be seen, but they're brighter. They're brighter. Now, you got to realize, this is weird. I thought this was an infrared telescope. Well, it is. But through their computer programs, they adjust so that they can translate, just like the colors on the galaxy, they are translated into light that we can see with our eyes, even though you wouldn't see this yourself if you were looking up. A couple of interesting points. How much of the sky are we talking about? How much of the sky is this? Well, if you had a grain of sand and you held it up at arm's length, that's all we're talking about.
So
That's all. All those galaxies in that itsy bitsy little area. Okay. A typical galaxy has around 250 billion stars. This thing has thousands of galaxies when you zoom on it. So this speck of sand is showing the equivalent of about 250 trillion stars. Now, one of the neat things about this too, you see how some of these galaxies are kind of curved, which is really weird. You don't see any of that over here at all. Well, they're not curved because they actually look that way, but this is taking a view of space that is not on a flat plane. There are some galaxies here that it's capturing, and some here, and some here, and some here, and some here, going all the way back. So the galaxies at the far back of the photograph are influenced by the gravity of the galaxies in front of them. Remember, Einstein even said that light is affected by gravity? Remember all those things about black holes, how even light cannot escape a black hole, get sucked in? This is kind of the same idea. This is called gravitational lensing. So from the light of those very distant galaxies, when it starts moving towards us, as it hits all these other galaxies, it gets bent a bit. And it keeps getting bent a bit more until to us, it looks like a curve. Those kind of things show up in the infrared. They don't show up in visual astronomy. That's one of the nice things about the Webb here. So,
But again, we're looking at it how many light years away.
Exactly.
So, but that doesn't exist right now. At some point it existed.
yes, the image that we're seeing is the image that would have been billions of light years ago.
It's just so unfathomable.
It is, yeah. Now, this one came out in just the last week or so. This is Galaxy IC, that stands for Index Catalog, 5332. This is what Hubble came up with for that galaxy. It's kind of the left side of it. And then they brought in Webb's right side of the same galaxy. You might say, well, I kind of like that more. That's a little prettier. But there's a lot more detail in this that comes out. Excuse me. They call that the bones of the galaxy are now visible thanks to Webb. So we can see the structure of all these gaseous combinations. Once again, the colors showing the different kinds of elements. Whereas all of that is obscured through the dust. And Webb, as an infrared, can see through the dust very well. That galaxy is about 66,000 light years wide. So it's about a third of the size of the Milky Way. We have a darn big galaxy. You can go home tonight and be proud of that. We have a darn big galaxy, the Milky Way, for that. Now, why can the Webb see so much more than Hubble? Well, this is a spectrum of all possible light, all possible energy. And if you can see this little black rectangle here that has kind of the rainbow inside, that's the only part of the spectrum that we can see. That's called the optical spectrum. If you take this kind of grayish rectangle that surrounds it and then goes in both directions, that's what the Hubble Space Telescope could see. It could see a little bit of the infrared. It could see a little bit of ultraviolet, but still not that much. Well, this big blue rectangle is what Webb can see. Good chunk of the entire infrared, a little bit of the visual too. So it just can see so much more of what is out there. All right, so I keep coming back to this term. Why infrared? Why did they make that decision? Well, 3 reasons at least. There are some relatively young objects out in space, in particular planets that don't have a lot of heat or light associated, but they have a little bit. And the Webb can see those much more than just an average visual telescope. Reason 2, and I mentioned this a minute ago, a visual telescope is obscured by clouds of dust, which is not that different from when I set this up and those actual clouds obscure my view. But clouds of dust up in space, the stuff that comes together to make stars, that can be hard to see through, but not for infrared, not for Webb. You can see through that quite well. And then this is where it gets complicated. And this is the physics here once again. Talking about the huge universe. Well, did you realize that the universe is not done growing? It's continually expanding. Sometime it'd be neat to have somebody talk on, well, if this is the current edge of the universe, what's out there? What's on the other side? That's a whole other topic.
Yeah.
But as the universe continues to grow, and these ancient galaxies that we were just referring to also go there too, their light moving away from us, that light gets shifted. Doppler effect, does that term ring a bell? You know, when you're standing like on a roadside and a car is going by with its horn honking, and it starts off down here kind of high, then you hear it go down. That's the Doppler effect in sound. As it moves away from you, the sound shifts. Well, the same thing with light. As light shifts, moves away from you, and no longer keeps its white color or whatever it is. The farther away it moves, the more that white gets shifted over to the red. Well, the infrared, which the Webb telescope can see, is designed to see those. So not only can he see I'm personifying the telescope. Not only can it see all those things, but it means that it can see way back to the early days of the universe. 13.7 billion years ago is supposedly when the Big Bang took place. Once again, 13.7 billion years ago. We think that the Webb will be able to see back in time to about 13.3 billion years ago. So we are going to be to see back to the infancy of the universe. So this very distant.
We're gonna see it happen.
Well, we're going to see what the light
Because you're
looked like.
going back and now you're bringing the Big Bang here to right here.
Well, we're not bringing it back, but we're seeing what the light looked like just a few billion years after the Big Bang. That's what we're seeing, the light. It's like if I had a special periscope that let me look back in time. That's what this does.
So excited.
It is. You know, this works on a small scale too. Disaster movie time. Let's say the sun blows up right now. Are we going to know about it instantaneously? No, it's going to take about 8 minutes for us to know about it. Okay, even with something like the sun, it's not instantaneous. Light takes a while to get there. So the same kind of idea is going on with this. Now here's some early images. This is an early image from Webb. These are all Webb images of Jupiter. Now you might think to yourself, that's not as pretty as the other pictures I've seen of Jupiter. And that may be right, but there's a lot more detail than is in the typical picture of Jupiter. Do you see anything there that you didn't even realize that Jupiter had?
Rings.
There's the big spot. That's what we usually call the red spot. Rings, yes. Did you know that Jupiter has rings? Just like Saturn, just like Saturn. There's the typical, it's not red in this movie, there's the typical storm that goes on forever. All these little white ones are apparently storms too. Those usually don't show up. This up at the top, can you see what that says? An aurora. An aurora at the northern pole, another one at the southern pole. All of this is coming to us through the infrared information that we're getting through Webb. So there's a lot more that could be seen. Here's another early image. This is my favorite one so far. This is called Stefan's Quintet. Have any of you seen this one before? Okay, those are 5 galaxies. 5 galaxies. Now, it seems from the perspective of this picture that all 5 of them are very close together. Well, once again, that's kind of an optical illusion. These 4 on the right side are very close together, and they form an interacting quadruple of galaxies. This one is actually much closer to us. So the 4 may be back here, the 5th is out here, but from the image that we've taken, it makes them look as if they're all together. So that one on the far left is very closer to us. We've also learned from this data that this one up here at the top has a supermassive black hole in the center of the galaxy. You can't see it because it's all the bright light that surrounds it. But just like the Milky Way, that one has one too. Now, some early surprises from the Webb, even though it's only been up there 4 or 5 months. It provides such intricate detail that we thought we had everything about the planets basically figured out. Well, some of the early data that's coming in doesn't fit 100% what we thought was true. So some of our models for how all this works may have to be revised. And then kind of related to that, and this one, I call it an early surprise, but it's really not a surprise. Scientists were so eager to get their hands on this data that a lot of the data from the early images before the Webb was thoroughly calibrated was used by a bunch of eager astronomers to come to new revolutionary conclusions. Now that it's been calibrated, the data's changed. So some of those early surprising things in the newspaper may have to be changed just a bit. Oldest galaxies, oldest stars. I remember seeing, I think it was within a month of when it went online, maybe in August. The headline, something to the effect of, we think we have now found the oldest galaxy out there. Well, maybe not. Maybe not. There may be some other ones that are going to be even older because of that calibration. We talked about how it can't be fixed. Well, you may have seen in the paper just the last 3 or 4 weeks, there have been some micro meteoroid hits on the telescope already. They expected this. But there was one that put a fairly sizable hole in one of the sunshades. Not enough to really cause damage, they think, at this point. But that's something else they're going to have to deal with. And then finally, this also was in the news just in the last week or two. This is the mid-range infrared imager on the telescope. One of the grading wheels that would be used to help focus the telescope apparently has more friction than it should. This is a hardware problem. So they're hoping they can fix that with just some computer rewriting of programs. But we'll keep our fingers crossed on that too. This has been a heck of a lot of fun, people. I've really enjoyed it.
It's been wonderful.
If you're curious, these are some great articles, some sources that I would recommend. And I printed up some copies over there on the table. I think there are 4 or 5 copies there. And once again, I'm not a professional astronomer, but I love this stuff. So I do a lot of reading on it. I can try to answer any more questions you have.
I want to know if your boys, your sons caught the bug. I mean, do they think, Dad, like you're just, you're just out of limits here? How about the little boys? Are they going to be taken to planetariums and ask Grandpa all about the galaxy and the constellations?
I think the answer to your basic question is yes, they certainly like it too. In particular, they were Star Trek boys. They love Star Trek, so all of that associated with that.
Yeah.
But my brother-in-law, who is a professor in New Zealand, is actually on a 1-year fellowship at the Air and Space Museum, the Smithsonian Museum in DC. And that museum has been shut down now for a long time for renovations, and it's just about to reopen. But this last weekend, they had a special pre-opening for people who had connections. So since he is on a fellowship there, and our 2 sons and their families live in the DC area, they got to go and see.
Oh, how exciting.
Yeah.
That's great.
So did you get to go?
I did
you go
not.
down?
No, we were invited, but we couldn't get to DC last weekend. It's supposed to open up to the general public, I think, the next month or 2. But have you ever been to the Air and Space Museum? It is amazing. It's remarkable.
I was just checking for verification. It wasn't on the website, but the Museum of Science and Technology did it down in Armory Square has had an exhibit on the James Webb, where they had images during the construction phase, assembly phase, as well as images taken by the telescope in an exhibit that was provided by NASA.
Oh,
But it's a temporary exhibit, and it's not listed right now. I know it was there like a week ago, though.
okay. That's good to know. Well, thank you very much.
Thank you.